In this video, we'll be talking about arc length. Now we know that the length of an arc is proportional to the circumference of a circle in the same ratio as the measure of a central angle of that subtended arc is to 360. So the two bottom parts of this proportion represent the entire circle, and then the top parts represent the arc that we're dealing with. Now, if our central angle is in radians, all that changes is instead of 360 degrees representing the entire circle, we have 2 pi radians representing the whole circle. So this gives us a formula. If S is the arc length and theta is the radian measure of the central angle, then the arc length, S, is equal to the radius times the central angle. Basically, we just substituted S for arc length. And then notice here we can cancel the 2 pi's that are in the denominators. So we have S over R equals theta over 1, which multiplies out to S equals R times theta. Let's do an example. A circle has a radius of 25.60 centimeters, and we're asked to find the length of the arc intercepted by a central angle having each of the following measures. The first measure is 7 pi over 8 radians. Now, since our central angle is in radians, we're just going to use the formula. Arc length equals radius times theta. So our radius is 25.60, given in the problem, and our central angle is 7 pi over 8 radians. When we multiply those, we get approximately 70.37 centimeters. Let's show you that on the calculator. .60 times 7 pi divided by 8. We get 70.37 centimeters. So just use your pi key when you're using your calculator. Right. The next part of this problem, using the same radius of 25.60 centimeters, this time our central angle measures 54 degrees. Now, since the angle is in degrees, we first need to convert to radians using pi over 180 multiplier. So 54 degrees multiplied by pi over 180 is equal to 3 pi over 10 radians. Now that our angle is in radians, we can use the formula. Arc length equals radius times theta. So 25.60 times 3 pi over 10 radians gives us approximately 24.13 centimeters. Our next example, Erie, Pennsylvania is approximately due north of Columbia, South Carolina. The latitude of Erie is 42 degrees north, and that of Columbia is 34 degrees north. We're asked to find the north-south distance between the two cities using the radius of the Earth is approximately 6,400 kilometers. Now a sketch of this. Remember that the equator is 0 degrees, and so Columbia is at 34 degrees. Latitude and Erie is at 42 degrees. And since we're looking for the north-south distance between these two cities, we're basically looking for this arc length. So the first thing we want to do is find the number of degrees between the two cities. So if we were to draw a central angle connecting the two radii, the central angle would measure 8 degrees. Then, in order to use our formula, we need to change that to radians. So we multiply 8 degrees by pi over 180, and we find that that central angle measures 2 pi over 45 radians. Now we can use the formula. The radius of our Earth that we're using is 6,400. Multiply that by the central angle in radians, which is 2 pi over 45. We get 893.6, which we will take to two significant digits, so 890 kilometers. Our next example, a rope is being wound around a drum with a radius of 0.327 meters. How much rope will be wound around the drum if the drum is rotated through an angle of 132.6 degrees? Again, we're looking for arc length. Before we can use our formula, we need to change our degrees to radians. Multiply 132.6 by pi over 180, and that gives us approximately 2.314 radians for our central angle. Now we can use our formula, arc length equals radius times theta, and so we have the radius of the drum, which is 0.327, multiplied by the central angle in radians. This multiplies out to about 0.75678, which we will take to three significant digits, so 0.757 meters. Our last example, two gears are adjusted so that the smaller gear drives the larger one. The radii of the gears are 3.6 inches and 5.4 inches. If the smaller gear rotates through 150 degrees, through how many degrees will the larger gear rotate? Now there's several ways to do this problem. I'm going to start by changing my 150 degrees to radians so that I can use my arc length formula. So if I convert 150 degrees to radians, I get 5 pi over 6 radians. Then I can use the formula to find the distance through which the smaller gear rotates. In other words, the arc length. So I have arc length is equal to the radius of the smaller gear times the central angle of the smaller gear written in radians. This arc length is approximately 9.425 inches. Now the distance, or the arc length, for the two gears is the same since the arcs are connected with the little teeth. So we'll write then that this arc length is equal to the arc length of the bigger gear, which we'll write as the radius of the larger gear times the central angle of the larger gear. Now when I find theta, that's going to be in radians, so I'll need to change that to degrees. Divide both sides by 5.4, and I get theta is equal to 1.745 radians. So the question asked how many degrees will the larger gear rotate. So I need to change my radians to degrees by multiplying by the unit multiplier 180 over pi. And I get my number of degrees that the larger gear rotates is 100.